Hey everybody, welcome to video 10-4C. This is the last one in our series of videos on section 10.4. And in this section we're going to be identifying what the figure is on the coordinate plane. So this is more headed towards what you're going to see for the rest of today and the rest of this week and on your quiz, which is here are 4 points, you tell me what it is. So if you can see in the wording for example 3, use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or square. Give all the names that apply. Now look specifically, they asked us to use the diagonals. So we know as we connect diagonal points, we have AC and BD that we're going to be working together with. Now here's our graph. And so if it's going to be a rectangle, first we're going to determine, are the diagonals the same length? So length is our distance formula, and as we calculate our distance formula for AC, we get 8 minus 0 squared plus 6 minus 2 squared. And as we go ahead and calculate that, we've got 64 plus 16, which gives us 80, and simplifying that to simplest radical form, we get 4 radical 5 there. Then we want to see if that length is the same as the length BD. Now you can probably see from the diagram that it does not look like it's going to be a rectangle, but we still have to prove it. So now we're going to prove it with the length of the diagonal BD, and in that case we're going to get 5 minus 3 all squared plus 2 minus 6 all squared, or 4 plus 16 under the radical, so radical 20 instead of radical 80. You can clearly see 2 radical 5 and 4 radical 5 are not the same, and therefore it can't be a rectangle. But remember, it could be some of the other things that we were asked. So if it's not a rectangle, we know that it could possibly still be a rhombus. We do know if it's not a rectangle that it can't also be a square, but it could still be a rhombus, so let's check that out. Step 3 asks us to determine if it's a rhombus. Now, if it's a rhombus, its diagonals, remember, are going to create right angles, so they're going to be perpendicular. So let's calculate this now by using slope. The slope of AC between these 2 points here, we're going to go with 6 minus 2, y2 minus y1, over 8 minus 0, and that does simplify to 1/2. So we have BD next that we need to find the slope of, 2 minus 6 all over 5 minus 3, and we get negative 4 over 2 simplifies to negative 2. And since those two slopes have a product of negative 1 or are opposite reciprocals, whichever way you want to think about it, then those two diagonals are perpendicular, and therefore ABCD is a rhombus. So rhombus is what we would write here after all these calculations to wrap that up. Now notice we did a couple of different formulas just using the diagonals. So we're going to continue that with part B on the next page. Now we're given 4 new points, E, F, G, and H, and we're first going to determine, is it a rectangle? So let's fill in the rest of this distance formula here. E, F, G, and H, we're finding first the length of EG. Here's E and here's G. And so x2 minus x1 first. We're going to do 3 minus negative 4. And then 0 minus negative 1. So that's going to give us, if we were to do our subtraction, 7 squared plus 1 squared, or 49 plus 1 is 50. And then don't forget to put that in simplified radical form. We have a perfect square of 25 that can come out of that. So 5 radical 2 is my answer there. Then we want to go ahead and find the distance of FH. So from F to H here, here's x2 is 2 minus negative 3 to begin with. So you know the direction we're subtracting. So 2 minus negative 3 all squared. And then finally we have negative 3 minus 2 all squared. And you can see again you've got 5 squared and another 5 squared, or negative 5 squared, same thing. Off to the side, we're going to get, again, a square root of 50, and then another 5 radical 2 for our lengths. So since 5 radical 2 is the same as 5 radical 2, the diagonals we know are congruent, and so we can say that EFGH is a rectangle. So it definitely is a rectangle because we've determined that the lengths of the diagonals are the same. Next, we want to say, is it also a rhombus? Because if it's a rectangle and a rhombus, remember the baby that they have together, the rectangle and rhombus families put together, gives us a square. So if we can say yes to step 2 and 3, we know we can also say that it's a square. Let's see what step 3 gets us. So now we're going to determine the slope of EG to begin with, rather than its length. And we get 0 minus negative 1, again, E and G here, y2 minus y1. So 0 minus negative 1 over 3 minus negative 4, we get 1/7. Comparing that to the slope of the other diagonal, which is FH, we get negative 3 minus 2 over 2 minus negative 3, and we get negative 5 over 5, which comes out to be negative 1. Now if we look at the product of 1/7 and negative 1, we do not get negative 1. So that means that those diagonals are not perpendicular. And so EFGH is not a rhombus, and also, remember, cannot therefore be a square. So the best name, the most specific name that we can come up with is that EFGH is a rectangle. So that's the process, you guys, that we're going to go through and that you're going to go through right now with the your turns, number 9 and 10. Again, focus on just using those diagonals to determine whether the parallelogram that's given to you could also more specifically be called a rectangle, a rhombus, or whether it's both and it's a square. Okay? And that's where we're headed for today. This takes us to the end of our last video for 10-4. So we're moving on to some new practice. See you later.